Now that we've looked at the complex plane, plotting complex numbers, and finding the magnitude of complex numbers, we're going to look at the trigonometric form of complex numbers. First, I want you to get used to this form, z equals a plus bi. This is the standard form. The standard form of a complex number is z equals a plus bi, which is the form we were using in the first video. You can write complex numbers in a trigonometric form. What we realize is, if we have some point, we'll say our point is 4 plus 2i. That puts our point here. We already know how to find this distance here of the point from the origin, and then that's our magnitude of z. What we then can realize is if we take this angle theta, let me make this a little bit bigger to see. Okay, we have the point 4, 2i. We know the distance of that point from the origin is called the magnitude. We could then look at the angle here, theta. Then this vertical height is the sine of theta times the radius, which is the magnitude. And this horizontal distance is the cosine of theta times the magnitude. So my ordered pair can be now given as magnitude sine theta, or I'm sorry, magnitude cosine theta, magnitude sine theta, which means z can be written as the magnitude of cosine theta plus the magnitude plus I times the magnitude of sine theta. We can factor out the magnitude. So as a final equation, we get the magnitude times cosine theta plus I sine theta, which actually leads us to the equation that you have here, where z can be written as the magnitude of cosine theta plus I times the magnitude of sine theta, or we can pull this magnitude out front and have cosine theta plus I sine theta. What you need to know is you need to know this equation and how to apply it, as we'll look at in example 3. The way we apply it is we use what I've given you here, where you see again that the magnitude is the square root of a squared plus b squared, and it's essentially the radius of our point. The angle theta is called the argument. And the way we find theta is we take tan, we know that tan of theta equals a over b. Because a actually this should be, if this point is a comma b, it should be b over a. Because a is our horizontal distance and b is our vertical distance. And tangent is opposite over adjacent. So what we see then is that theta equals the tan inverse of b over a. Well, let's apply these. If you want to, you can try this problem on your own first and resume the video when you're ready to check your solutions. Otherwise, follow along, make sure A makes sense, and then maybe try B on your own.